So today we do the weird rule of what? Of what if we have a what? A negative exponent. We have seen negative exponents, but all we did with them is either add them or what? Or subtract them. But what if you only have one single negative exponent? What does that mean? Okay, you know what? I'm not going to tell you what that means. Let's actually discover it together. Let's do some observations. Okay, let's actually discover this together. So in the following table, come on. So I'm going to do two kinds of examples. One with what kind of a base? Positive, and one with negative. So let's see. Do they lead to different rules? Do they lead to the same rule? I don't know yet. Let's actually find that together. So all we have to do is basically what? Fill the value column first. What's 3 to the power of 3? So 3 times 3 times 3. 27. We do not have a disagreement there. So go ahead and just write. I'm going to do it in blue. 27. Okay. All right. How about 3 to the power of 2? 9. 3 times 3 is 9. Okay. Before we go to the next one, question for you. How do you go from 27 to 9? Obviously, you could say, well, one way is to subtract 18. I'm not saying that's wrong, but there's another way. One way to go from 27 to 9 is to subtract 18. 27 minus 18 gives you 9. There's one more way. Hamza? Divide by what? By 3. Interesting. Okay. So go ahead, and all you have to do now is make an arrow like this. Sorry. And just say what? Divide 3. Okay. Not bad. Okay. Let's keep going. How about 3 to the power of 1? Anything to the power of 1 is just what? Yes, it's not 1. It's what? Itself. So this would be 3. How do you go from 9 to 3? Do you follow the same pattern? Do you also divide by 3? Okay. So there's no reason to believe that this trick will ever what? Fail. All right. Okay. Does anyone remember what's any number to 0? Any number, or not just any number, anything to 0? No. See, that's the trick. Any number. By the way, I'm going to teach you that tomorrow. But one way to explain it today is anything to 0 is what? 1. Let's prove it. What's 3 divided by 3? You see, the 1 is the one that actually what? Satisfies the trick. Do you see what I mean? The pattern here, divide by 3, divide by 3, divide by 3, tells you that your next answer is what? Your next answer is 1. So anything to 0 is 1. Tomorrow I'm going to show you another way to understand why it's 1. Today, let's just say because of the pattern, it has to be 1. So 3 to the 0 is 1, which follows from the same exact pattern. All right. Okay. Now we go to the what? To the gray cell, to the gray boxes. What's here? 3 to the power of what? No. 3 to the power of? By the way, if you when you say minus, it's a whole different what? It's a whole different game. Let me ask you a question. Even if I don't know this, should I believe that this pattern keeps going? Okay. What is 1 divided by 3? Come on. What's 1 divided by 3? Now, you can give me a what? An infinite decimal, or you can just say what? What's 1 divided by 3? If you just want to keep it as a fraction. No, not 3. 1 divided by 3. You just write what? 1 over, nice, over 3. So go ahead. 1 over 3. Okay. You might see that in the first 3 boxes, what did I say under, what did I say under trick? I said what? None, no need. None, no need. None, no need. Now we're going to start needing what? Needing the what? But let's keep it till the end. Let's finish the what? The first column first. All right. Let's keep going. Okay. Can I still divide by 3? Yeah, we're never going to stop. Okay. Who would like to tell me what's 1/3 divided by 3? Okay, let's review our division with fractions. Say again. You got the right idea, but it's not 1/6. Everyone. 1/3 divided by 3. Can someone tell me how to do this from like grade school? How do we divide fractions? Make the second one a fraction. So obviously this one will be 3 over what? 1. Okay, let's keep going. Yes. Do we like to multiply more or divide more? We like to multiply, but I have to pay a price. What's the price to change this one to a multiplication sign? This one has to what? You never flip the first one. You always flip the second one. So you multiply. That's your prize. So that's your prize. But the price you have to pay is this. And what's 1/3 times 1/3? 1 times 1 is what? 1. 3 times 3 is? Good. All right. So this would be 1/9. Okay. Let's keep going. Divide by 3. Who would like to tell me what's 1/9 divided by 3? Or in this case, multiplied by 1/3. How much? 1 over, you got it, 1 over 27. Okay, I guess we're seeing what's happening now. So obviously there's no more to go into a very long list, but let's just do maybe, how many do I need? 1 or 2 more? Okay, just 1 more, so perfect. So again, divide by 3. So what do we get here? What's 1/27 divided by 3 or multiplied by 1/3? So really you're asking yourself, what's 27 times 3 down there? One, not quite. 81. Thank you. 81. Perfect. So we got the first column done. The question now I'm going to ask is, what should we put in the what? In the trick column. Ladies and gentlemen, let me show you the trick. Okay, everyone, just focus here. Everyone, pencils down. Question for you. What's my exponent right here? -1. Technically, what is this number? Which means what's the power here? Okay, okay. What's my exponent here? What's this number? 9 is 3 to the power of just what? What's my power here? What's this number? 27 is 3 to the power of what? No, no, just 27. 3 to the power of? What's this? What's this number? Sorry, what's this exponent? What's this number? 81 is actually 3 to the power of just what? So can someone guess the trick? Can someone guess the trick? You actually don't have to guess it. It's right there under the table written in the big box. Can someone tell me what the trick is? In their own words. You don't have to read what I showed you. In your own words. Okay, everyone, I'll say the trick again. What's this number? What's this number? -2. What's this number? But it's actually what? 3 to the power of? Just what? Huh? Okay. What did we do yesterday? But yes, so you mean not yesterday, the day before yesterday? Yeah, but we subtracted. We're not subtracting or adding here. What is the trick? Come on, people. Who noticed it? I'm just asking you. When you have a negative here, how do you fix the situation? The negative can turn into a what? Positive. But where does the whole thing have to go? There you go. That's it. So everyone, can you write this like this? Check this out. Who agrees that I can write this? How many people agree those are the same thing? Raise your hand if you agree those two are the same thing. 1 over 3 and 1 over 3 to the power of 1. Okay. Do you agree that this one right here could also be written like this? So can someone tell me how to write the next one? 3 to just what? To the power of 3 or -3? No, no, no. It used to be -3. When I flip it, what does it become? You see, you always have to pay a price, but you get a what? You get a reward. What's the price you have to pay? You have to what? That's the price. What's the prize? You get the what exponent, negative or positive? There you go, positive. 3 to the 3. Last one. Yes. Sorry, what's up? Yeah, yeah, yeah. Sure. Go right here. So everyone, listen up. Let's look. What's my power here? Come on. What's my power here? What is it here? You see how easy the trick is once you discover it? Okay, let's do the next column. But the next column is different because my base is what? Come on, what's my base? Negative. Okay, let's see if the same rule applies. Although we have negatives, so we have to be slightly extra careful. Okay. Okay. What's negative 5 squared? Come on, people. Negative 5 squared. So negative 5 times negative 5. Negative 25 or positive 25? Hold on. Positive. When you multiply a negative by itself twice or 4 times or 6 times, you get a what? You get a positive. So let's just write positive. Okay. How about negative 5 to the power of 1? Anything to the power of 1 is kind of like multiplying it by 1. It's not the same, but it's kind of like it. Negative 5. Can someone tell me how to go from 25? Okay, forget the negative for now. How do you go from 25 just to 5? Just to 5. You divide by, but I need to go to what? No, 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 no. I need to go to what? I need to go to negative 5. So I don't divide just by 5. What's up? Sorry? No, no, no. Hold on. Relax. Does any No, no. Does any number ending in 5, doesn't it also divide 5? That's always the easy one to do. So 25 divided by 5 will give me what? No, will give me just what? 5. But I don't want 5. I want negative 5. So I have to divide by what? Negative 5. Yeah, and you know what? You don't have to. If you don't believe me, here it is. Look, 25. Oops, sorry. 25 divided by what? 5 with a what? Gives you what? Gives you negative 5. That makes sense, right? All right. So everyone, let's do the trick here. Divide by. By the way, do you have to put the negative 5 there in a bracket like this one? Can you? Can you? Yes. But again, we know what's going on. All right. What's negative 5 to 0? Anything to 0. Solid 1. Again, you don't have to believe me. Here it is. Shadi, give me a number. Any number you want. 25 to the power of 0 equals 1. That's it. We're done. What's up? Yes, but I have to put it in a bracket. All right. Look, everyone. Okay, Haley, give me a negative number. Anything you want. Negative 10. So I have to do this, everyone. Look, bracket 10 with a negative, and then close the bracket. Aha, so now it's waiting. To the power of what? 0. To the power of 0. 3, 2, 1, go. 1. Never fails. By the way, you could have given me a fraction. And say decimal 5.3658 to the power of 0. 1. Never fails. Okay, so at least we know that. Tomorrow I'm going to even show you more proof why it works. But today let's just say we know why it is. Okay, so again, this is what? How do you go from negative 5 to 1? You divide by what? Now, you have to keep dividing by the same number, which is what? You never change it once. You have to keep going down in the exact same way. Negative 5. All right. Okay. Now, what's negative 5 to the power of negative 1? I don't know. But can we do the same trick? Yes, we can. All right. So let's divide 1 by negative 5. What's 1 divided by negative 5? Okay, hold on. Let's take it easy first. What's 1 divided by 5? Just what? Like Kareem said, that 1 divided by 5 is 1 over 5. But I'm not dividing by 5. I'm dividing by what? No, I'm dividing by what? Negative 5. So technically, I have to put what? Look, everyone. I have to put 1 over what? By the way, do you remember when Louisa asked me, is it okay to put the negative down at the bottom? What did I tell you math teachers say? Is it acceptable or not acceptable? Huh? It's not acceptable. Is it wrong though? It's not wrong, but we always put the minus where? Either where? At the top or no, never at the bottom. Try it with any math teacher. They will always almost take half a mark off. You cannot, you are not allowed, you are not allowed to put it at the bottom. You either put it where? At the top or where? On the side. So everyone, you either put it here or where? Right before the fraction sign. Okay. Can we leave it at the bottom for today? Yes, because we want to see the parent. We don't want to change it. Okay, can I go again? Yeah, we're going to keep going down the ladder. All right, so I'm going to divide by how much? Yeah, never change it. You divide by negative, you have to divide by negative every time. What's 1 over negative 5 divided by negative 5? Let's go back to our blueprint here. 1 over negative 5 divided by negative 5. Why? Explain it to me. This negative 5 here should be over what? 1. So it becomes what? 1 over negative 5 times what? Over. Yeah, because I'm going to flip these two, right? Okay, what's 1 times 1? What's negative 5 times negative 5? You got it. You got it. By the way, I guarantee you, if you go now to have the students in grade 11 and grade 12 university math, and you show them this, without the one, half of them are either going to be what? Just looking at it and having no idea what to do, or they would do it completely incorrectly. They would either maybe not flip or forget the minus when they flip, but they are not what? They forgot how to divide fractions. Okay, so what's the answer here? Sabine? 1 over what? 25. All right, come on, people. Let's keep going with the parent. Who would like? Okay, can someone tell me if my next fraction is going to be positive or negative? Let's actually watch what's going on. What's this number? No, what's the sign? You see, they alternate because when you divide by a negative, you change signs. All right, who would like to tell me what this one is going to end up being? 1 over negative what? 125. You got it. Come on, two more to go. What's up? Is it positive or negative? Everyone, is this one positive or negative? It has to be positive because the pattern never fails. Negative, positive, negative, positive. 625. And then finally, who would like to, you know what? I'll spot you the negative. Just give me the number. I know the number. 55555 is 3,000. Hamza, yeah? 125. Okay. 125. Okay. Let's go to the trick. Let's go, everyone, to the trick column. All right. Do we need tricks for the first three? Everyone, do I need trick for the first three? By the way, when your exponent is what? Listen up. Everyone, when your exponent is what? You do not need a trick. If your exponent is what? But if your exponent is positive, there's no need for a trick. You only need a trick once you have a what? Okay. How many people agree? Listen up. Okay, everyone, watch this. Because now I'm going to create the trick for you. How many people agree that this one is equal to this? Is equal to this. Come on, everyone, focus. How many people agree that this guy is the identical twin of this one? Because anything to one is just what? Anything to one is just the what? The thing itself. Okay. How many people agree that this one right here? Raise your hand if you say yes, this is true. Because bless you, negative 5 squared is just what? Come on. What should be the next one? 1, 2. Keep going. Everyone, if I wrote this, would that be correct? If you flip, you have to also make the what? Make the exponent what? You cannot flip and keep the exponent what? Negative, because then you did nothing. You pay a price, but you get a price back. The price you pay is flipping. The price you get back is we don't have negative exponents anymore. We just have what? Positive exponent. Nice. Ladies and gentlemen, that's the trick to what? Dealing with any negative exponent. Just flip and get the positive number. Okay. So yeah, let's summarize, everyone. Okay, so everyone, let's summarize. Come on, eyes with me. So what is the rule for negative exponents? A power with a negative exponent and then a what? Everyone, my base was always what? A what? It was what here? No, what was my base? No, base 3. What was my base here? Negative. But they were what? They were still what? Whole what? Whole numbers. I did not use fraction. I'm using whole numbers. So a power with a negative exponent and an integer base, like a whole number base, is equivalent. Can someone tell me what's the word equivalent mean? When you say similar, consistent, same as, thank you. So everyone, let's just put same as. Go ahead, write same as. Equivalent means same as. Maybe not identical, but equally the same effect. Okay? Is equivalent to the what? To the, ooh, who can read that word? I don't use it much, and I'm not going to use it much, but I just need to hear it once. Reciprocal. Can someone tell me? Reciprocal. Reciprocal. Okay. Okay. It's made, yeah, the second R. Everyone. So think of it as made of what? 4 small parts. Reciprocal. 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 Okay. What does it mean in simple English? Flip. Okay. Here's the, okay. No, hold on. Here's the thing about the word switch. The switch could mean what? From right to left. I'm doing what? Top to bottom. So flipping is that. So go ahead and just write flip. Of the base to the what? Come on, everyone. Okay, well, what's the opposite exponent of a negative one? Come on. What's opposite to negative? Yeah, so I want you just to cross this word, cross this word. No need to write it opposite. We know what it is. It's positive. So everyone, cross this word, just like cross it like this. And just write what? Positive. Done. This is the rule. So is this the same as the rule? What's my B? What's the B? It's the what? B is the base. And it's a what? Integer. It's a single number. To what power? Positive or negative? What happened to it? It got flipped. But when I flipped it, the B stayed as the same, but the minus n became what? Positive n. And what do you always put at the top? You always just put what? 1 at the top, and that's it. Everyone, one condition though. Your B can never be what? Your B can never be what? Oops, sorry. Your base can never be. Can someone guess why? Can someone guess why the B can be anything you want? Negative, positive, decimal, blah, blah, whatever. But it cannot be 0. Come on, people. What's one thing you can never do in math? No, you can't. 0 is amazing when you multiply because it does what? It kills everything, right? 0 times 5 is what? 0 times minus 10. 0 times x, 0. Can you divide by 0? Well, you know what? Let's put it to the test. Here it is. Hold on. Okay, hold on. Okay, everyone. What does, no, hold. What does 0 divided by 10 mean? I have $0, which is practically what? Thank you. I have nothing dollars, and I want to divide it by 10 people. Okay, I can, but technically I can do that. But what does that mean? They're gonna walk in and what? Walk out with how much money? So it makes sense to divide what? 0 by 10. Because that means what? I have nothing. So technically each person gets what? Nothing. But that makes sense. That means what? 0 divided by 10 is still equal to 0. Am I making sense? Oh. Do you see what I mean? I'm trying to give you. But my point is, there's still what? They came in with 0 money and they still came. which means what? The answer is still what? 0 as well. That's my point. Okay? So, no. There is no, and that's my point. There is no point because it makes what? It means that the math is still solid, right? Okay, great. That's what I want. So 0 divided by what? By 10 is equal to what? Is equal to what? How about if I what? Flip it. What's 10 divided by 0? Well, let's see what this amazing supercomputer was giving me, which is supposed to do everything. 10 divided by 0. Nope. Nope. The only number in the universe that you can never divide by is what? Is 0. I'm going to teach you something now that not even university kids know. Seriously. Everyone, I'll tell you why it doesn't make sense. Hold on. Everyone, pencils down. Give me 1 minute of your time. I will make you smarter than people who already made it to university or college. Check this out. And you know, when I promise that, I always deliver. Okay, everyone, Shadi, give me a number, any number you want. And don't make it a decimal, just make it a regular integer. 161, okay. You know what? Okay, okay, hold on. Let's divide it by 10. All right. No, that's fine. No, you know what? Good, because I'm like a magician who does not control the crowd, right? I'll show you that it works no matter what. Can someone tell me what's 61 divided by 1? If you have $61 and you want to give it to 10 people equally divided, what do you get? Equally divided means 6.1. So each person gets $6.10 if you can give them cents. Okay, no problem. Are we good so far? No, everyone. Watch, look. What do I have here? I'm going to make it, look, I'm going to make it 1. What's 61 divided by 1? Great. Yeah. If you have $61 and you want to give it to the one person, they have to get the whole thing. Okay. Guess what my next number is? Okay. By the way, whatever that means, what's 61 divided by 0.1? You can. You absolutely can. 610. Hold. Oh, you got it. Okay, hold on. It's the same digits. Yes, you have to play with the what? With the decimal point. Okay, we're almost there. I told you, I'm not going to take more than a minute. What should be my next number? 0.01. Okay, don't plug it in. Look at the parent. What's this number? Come on. 0.1. What's this one? What's this one? What's happening? It's growing by what? 10 times each time. So what's my number now? Okay, I'm almost done. Now I'm going to divide by what? 0.001. 61 with how many zeros? Okay, we're there. 61 divided by 0.0001. Are you seeing the parent? What's happening to the top? Is anything happening to the top? What's happening to the bottom? Hold on. What's happening to the bottom? Is it getting bigger or smaller? My bottom is getting smaller. What's happening to the final answer? Okay. What's the smallest you can get here? What's the smallest thing? Again, you're making the number smaller and smaller. Yeah, okay, good. Okay, so Shad is saying what? Put as many zeros as you can. All right. Hold on. But I like the way you're actually seeing this. 0.00000. I'm going to have to put zeros forever. And at the end, I have to put what? 1. Okay, no problem. But this number would then be what? So small. It's almost what? Do you see what I mean? If you say I have a particle like an electron. How many people know electrons? Electrons are very big or very small? Electrons are very big or very small? Very small, which means are they very heavy or very light? So if you put them on a scale, everyone, if I use this scale, listen up. If I use this scale, I believe we have a scale here. We don't? Surely I did. I thought we had a scale here. Oh, no, that's not scale. Sorry, got excited for a second. If you put an electron on your bathroom scale, do you think it's going to read a value for it? Why not? Because it's very what? Very super what? So tiny and light, which means what? To the what? To your bathroom scale. Listen up, guys. To your bathroom scale, the electron weighs how much? Zero. Do you see what I mean? A very small number could be thought of as what? Zero. Which means, Shadi, if I have a near infinite number of zeros here and one, is this a big value or a small value? Okay, but can you tell me what's happening to this number? It's getting what? How big? So what's happening to everyone? What's happening to the size of the number? Come on. What's happening to the value of the number? It's getting what? Bigger and bigger and bigger and bigger. Do you think if the number gets big enough, we can actually show it on this machine? Can you ever think that they could ever invent, listen up, could they ever invent a supercomputer with an infinite display? Can you ever invent an infinite display? Like an infinite long display. Can you ever invent that? No. A display, no matter how big, has to what? Has to stop and end somewhere. What does that mean? Are you ever going to be able to ever show me the result of dividing by exact zero, which is an infinite number? That's why they tell you what? 61 divided by zero is what? You cannot divide by zero. Why? Because you will need what kind of a display? A small or an infinite one? That's the reason. Dividing by zero gives you what? Infinity. How many people here know the symbol for infinity? Does anyone know it? It's like an 8, but you do what? You flip it. So basically, eventually, what's the answer going to be? How many people know this value? This is it. Is it making sense now? That's why you can never divide by zero, because Hamza, you need what kind of a display? An infinite display. Can you ever manufacture an infinite display? Done. That's the only reason. Now you know more than people who are in first year. If you ask them, why can't you do it? They will tell you, I don't know, man. The calculator just says you can. By the way, can you do it on your cell phone? Let's see what message you get. Here, it gives me cannot divide by zero. What else can you get? Error. Or what? Math error, which means what? Something that is not acceptable. No. 61 divided by zero. Go ahead. 61. 61 divide by zero. Error. You can't do it. Yes. Sure. Okay. Shh. Haley? Yes, absolutely. Okay? Yeah, go ahead. Okay, so that means what? Cannot, we're going to say it cannot what? Divide by, come on. Cannot divide by what? By zero. Can you divide zero on the top? Yeah, no problem if zero is here. Because zero divided by anything is what? Zero on top, perfect. Zero at the bottom, disaster. Always remember it that way. Okay? So what are we going to say? So think of it as a price you pay for a reward you get. What's the reward? The reward is what? Your negative exponent becomes what? Come on, the reward you get is that your negative exponent becomes what? Come on, people. Your negative exponent becomes, so everyone go ahead. The reward is your negative, negative, negative. Uh, you know what? You can say power, you can say exponent. I will never penalize you for using either word. I'm just going to say exponent for today because it's officially the official name. Your negative exponent becomes, okay, let me just squeeze this. I can. Becomes what? Positive. Okay, that's my reward. What's the price I had to pay? Everyone look at me. I had to flip my what? My exponent or my base? I had to I had to flip my base. My base starts at the top. It goes to the what now? Thank you. So the price is you must flip. I like to write the word flip in quotation marks. Flip the base. That's it. That's as easy as it is to what to deal with negative exponents when your base is a single number. Okay? Okay, everyone. Um, let's flip the page. Yeah, no problem. Go ahead. Everyone, let's flip the page. Hamza, look at all the examples you have on the second page. All the bases now are what? Fractions. So now we're going to do what? The second case of this. I have a fraction base, but still with what kind of exponent? With a negative exponent every time. Okay? So everyone, let's go to the second page. Come on. There we go. Case number 2, fraction base. If the base is a fraction and the power is negative, okay. Can someone tell me what did we do with the base originally? We what? We flipped it. What are we still going to do now with the base? But now we have how many numbers in the base? 2, because it's a fraction. What do you do when you flip a fraction? The top becomes the what? And the bottom becomes the what? That's it. What again happens to your exponent? It goes from negative to, remember, it's the same price you pay for the same reward. All right? So you flip the fraction. Go ahead, flip the fraction and make the power positive. Ladies and gentlemen, here's the rule. Sorry. A power with a power with a negative exponent, and a what now? Fraction base. Fraction base, not an integer. Fraction base is equivalent, which means what? As Haley said, similar to, same as, identical to, kind of, to the reciprocal, which again means flip. Go ahead, flip of the base to the, again, it's not just opposite. It's what kind of an exponent now? Now, what's the new exponent? Positive. Ta-da. Noor, what's my original base? A, A, A over B. What's my new base? Did I flip it? I did. What's my old exponent? Negative something. What's my new exponent? The positive something. Great. Everyone, how many conditions do I have now? One condition or two? This time, neither the A nor the what? Come on, everyone. Neither the A nor the B could be what? Can you tell me why now it can't be either one? By the way, what was it before? It was only what could not be zero, just the what? Why is it two things now? It's fraction, which means what? In the old one, the B could not be what? In the new one, the what? Yeah, right. Whenever you have a fraction at any stage, the bottom could not be what? Thank you. So I want you to circle this, and say what? The bottom can never be zero. Yes. Let me just do a couple examples, and then all good. Okay, everyone. So let's do a couple of examples. Oh, that's weird. Why? Okay, I'm gonna waste. I guess it's already here. So we're just gonna write what? B over A to the end. Okay. Can someone tell me what did we do every time we had this? Oh, come on. Yep. Hello, everyone. Everyone, listen up to Rama and Sally. Come in. Yeah. Hello. So $7 for the sandwich and $7 plus $1 for the sandwich and the drink. Downstairs during lunch, all of lunch, student council. Yes. Into the computer. Okay, we're good? Yes. I can pick it up for you. No problem. Yes. Yes, you've got the big gun. Okay, thank you. Awesome. Bye. Can someone tell me what did we used to do when we had something over something to a power? Come on. We did it a few times uh, when we multiplied and we divided. Come on. Yeah. Muhammad said before, we multiplied. We don't multiply. What do I do with that n? It what? Where does it go? Where does that n go? Say again? On top, on the bottom, and also at the what? On the top. It attacks every part of the fraction. So again, Hamza, why do I say? Because you're not multiplying b times n. You're putting b to the power of n. See, multiplying and powering are not the same thing, right? 2 times 3 is not the same as 2 to the power of 3. That one gives you 6, one gives you 8. So everyone, I always like to do this and this. And there you go. B to the power of n, a to the power of n. No brackets needed. All right, let's do oh, again, let's write the same thing. What's your reward? Your exponent becomes positive, positive, and the price is your base, or you must flip. I'm not just gonna say flip the base, I'm gonna say flip the fraction. Flip the fraction. All right. Okay. Who would like to do the first one? First of no, first of all, what's my base? Is it an integer or a fraction? What's my power? By the way, everyone, listen up. If this was a 5, if this was just a 5, is this today's lesson? If this was just a 5, what do you just do? If this was just a 5, what do you just do? You just put it on top of the 4? No, no. If this was just a 5, not a negative 5, do I need to flip? No, you don't. You just put it on top of the top of the bottom, and that's it. But is it a negative 5? So what do I need to do first? Flip. So what's the flip of 4 over 3? Thank you. By the way, do you make either of them negative? Do you ever change the signs of the base when you flip? No, just top becomes bottom, bottom becomes top. They stay what they are. Good. So this becomes what? 3. Oh, sorry. 3 to the power of 4. What's my reward now? Reward positive 5. Thank you. And then, interesting. Let me write the 5 slightly smaller. You what? You distribute, or you put the 5 here and here. So 3 to the power of 5, 4 to the power of 5. So we have 3. Okay, who knows what's 3 to the power of 5? 381, 243. 243. What's 4 to the power of 5? 4 to the power of 5. 256 times 4. 1024. Sorry, 1024. By the way, do you think I'm ever going to give you such a thing like this to simplify? No, I wouldn't. Come on. Look at those numbers. Are they small or big? Yeah, I mean, it would take you. By the way, good news. It doesn't simplify. It doesn't simplify. By the way, everyone, do you want to know how you can tell if it's going to simplify without even doing any of this work? Everyone, look. Everyone, are those big numbers or small numbers? No, those big. 243. One. If you want to simplify them, it's probably going to take you what? It's going to take you time. Let's look at the original ones. What was my original numbers? Do they simplify, or are they as small as they can get? There you go. If your original base is already simplified, no matter how big your other base gets, it will never need to be what? There you go. But you just have to check the what first? The original. If the original one is good, your final one, no matter how big it looks, it will never simplify, and you just leave it like that. Okay? This one. By the way, does 4 and 7 simplify? I know it's a negative 7. Let's just look at the 7. Does 4 and 7 simplify, or do you think they are as small as they could get? Yeah, 4 divides 1 and 2 and 4. Guess what? 7 does not divide any of those but 1. So we're done. Okay, what do I do with the power? Sorry, what do I do with the fraction first? Flip it. When you flip it, Doesn't matter where you replace the minus, by the way. No, but let's keep it where it was with. It was with the minus. It was with the 7. Let's keep it with the 7. So minus 7 to the power. Sorry, to over 4 to the power of what now? Come on, 5. Okay. What happens? Attacks here. Attacks here. This one is 4 to the 5. Everyone, is this a good way to write this? Nope. Yeah. Yeah. Remember, when your base is negative, what are you always encouraged to write? Thank you. Brackets. Please, please. Always put brackets when your base is negative. Okay. What's negative times itself 5 times? A negative, because one of them is not going to pair at the end. So that's a negative. Now what's 7 times 7 times 7 times 7 times 7? Sorry, 1 second. Sorry, Muhammad, was it? 60,800. Like this? Oh, oh, is it 16,000? Oh, sorry, I heard 60. So is this correct? Yes. What's 4 to the 5? We already have it. Do you think this is going to simplify? Because this one did not simplify. That's the beauty of what? Fractions. If they grow, but they came from what? A non-simplified one, they will always stay non-simplified. Yes. Okay. I'm just going to do 2, and the rest will be your practicing homework. So what would this be? 5 to the power of what? To the power of what? Minus 3, yes. By the way, if someone tells you, everyone, if someone tells you, you can't put a negative there, what's your response? I mean, can you still put a negative? Yeah, it's going to be an intermediate step. Whatever you need to work it out at the end. Okay? So this is 5 to the 2 over what? But you need to use what? Thank you, because my base here is negative. Yes, what's up? What's Do you need to put brackets for the 5? Because it's a positive base. Oh, see, I'm not saying that. By the way, I always show you the difference between can you and should you. You should always use it with a negative. You still can do it with a positive. Haley, say again. So okay, perfect. Everyone, listen up. Look at everyone. So everyone, Haley's saying, could you have put the negative here? Yay. Hold on. Remember, in the negative could be put where? Could be. That's my point. However, that could be an intermediate step that you choose to do or not. 100%. So, yes. So everyone, you want to place the minus here? 100%. You want to place the minus here? 100%. You want to place it slightly before the fraction? 100%, although I wouldn't recommend that. Keep it with one of the numbers, okay? Keep it with one of them. So what's 5 squared? What's negative 3 squared? Whoa. Can you ever square a number and get a negative? No, because 2 negatives pair up to be a what? Positive. Thank you. Okay. Can someone tell me? Listen up, everyone. Last one. How many negatives do I have here? What do 2 negatives always do to each other when they're either multiplied or divided only? They always turn into a what? So can you keep them as negatives and put them positive at the end? Can you turn them into positive right now? Please, let's do that. All right. So what does this one become? Just what? No. The inside. The inside. It just becomes what? 8 over 3. My point is, can these two cancel? They do. That's my point. You can cancel them right now. So 8 over 3. Still with what power? Yeah, I did not flip yet. Now, say, what's up? Because what's a negative number divided by a negative number? What do two net? Yeah, that's my point. I just took them out. You see me? I just took them out. Okay, so what does this become? 3 over 8, all to the power of what? Come on. What's my new power? No. What's my new power? Just 3. I am. Yes. What's 3 times 3 times 3? 27. What's 8 times 8 times 8? 512. Do you think this will ever simplify? I don't even need to bother. Does this one simplify? 8 and 3? No, they don't share any numbers but the 1. That's it, ladies and gentlemen. That's how we do negative exponents.